Okay, so today we want to talk about the Open API CI/CD. Then I want to have like a couple of, I think 15 to 20 minutes to talk about time management at the end of the session, if we could. But let's see how this conversation can go.
Let's see, I can make a slideshow. Yes, so what we wanted to do, I will, for 15 minutes, I will introduce a whole sort of open API management idea and flow, and then all I will go to details and to show what is built and all more details. And then we'll go for the discussion regarding time management. So do you see my screen?
Yes, we can. Okay, sounds like a good plan.
Okay, so from my side, the plan is that, these are the topics. So what is open API-based platform development in process? Then what is the platform APIs versus service APIs, and where do we store them? And then, so we'll run on the example with machine learning on GPU use case, because it's most kind of developed sequence diagram, and we'll see how that match to how we work, or how we, let's say, the proposal to work. So the general open API-based platform development process would be that what we do first, we have what we know, we have milestone pages, which sort of, where is it? Milestones. So we have decentralized, GPU ML Cloud Phase 1. So this is a milestone on which we are working for building GPU, machine learning on GPU functionality. So now the way we do this, so we build a sequence diagram for that use case, where we build basically more involved explanations how this works. But most importantly, we built so we built this wiki page which contains entity diagrams, descriptions of entity diagrams, what kind of components are running on which entity within the NuNet network. Then we have description. I think we do descriptions on Google Docs. Then we have sequence diagram of all the calls that we want to implement in order for this to work. With all the entities that are defined in entity diagram, and all the APIs which we need to update or develop in order for those calls to work and exchange data and kind of requests and responses between each entity within this use case. The color codes are basically APIs that these touch. And the red one is something that is completely not described, but So then we build this sequence diagram from the perspective of how we want to implement the use case. Let's say from quite detailed, but still not completely sort of granular technical. And least but not last is we describe each call that we have on the sequence diagram. We make a Google Doc with description of each call, link to whatever links are needed, and also we describe. First of all, we describe it, and then this document is for discussion between developers what is exactly needed for that call in order for the use case diagram to work. So that is the first case. So as I said, we build precise sequence diagram for use case platform integration for each milestone, and then describe each call on that Google Doc, and we discuss it as much as needed in order to figure out what is exactly needed for that particular call. When the call is discussed enough to be implemented, we put this description of a call onto the API specification file in appropriate repository, and we issue pull request. I mean, these are developers who do this. We'll issue the pull request to merge the specification file. So this is the mechanics. All I will show after. And then we create an issue to implement that code as per description, and this is assigned to the developer who is responsible for the API implementation. And in the description, we separate the blocks the blocks that are needed for, part of this diagram that is needed to implement this particular functionality. And then we develop this diagram further as needed, because most probably we will sort of make it much more granular while implementing. Right, so this is general kind of team process of developing API. Now, what else do we have? It's going too fast. Well, we have two kinds of APIs. We have platform APIs. Right now, we have 4 APIs. So if we look at the again at our epics, to our epics. There is an epic called, what is it? Why don't I see it? Yes, here it is. So where we sort of figured out what kind of APIs we will need. Right now, we have we sort of identified that we need 4 APIs at least for current implementation, which is tokenomics API, telemetry API, specification device management API, and compute API. These are the platform APIs. They live in this repository, Open API. I think one is not yet defined, where we put all the specifications and we update them, like a code. So basically each developer, which will need something from specific API, will have to define the code that they need from it, describe the way that I explained and discussed, then put the description into the specification and ask a developer who is responsible for the updating the specification, responsible for API, to basically implement it. And the whole this open API management is the process of open API management is needed in order to manage all this flow of collaboration development based on that. Right, so we have three API specific. Right now, 4 APIs that we will need to specify from the platform perspective. 3 APIs already created. We'll create another one soon. Then what is a service API? Okay, that's kind of a mistake. Service. Okay. So service API is right. So here is basically the way, if we look at the structure of our repositories, we have components, platform components. They are in a root. Let's say root. Projects in root NuNet. These are related to, let's say, platform components like device management service, NuNet infra, etc. and so on, token contracts, pipe racking. Then all the work that is related, and then we have miscellaneous experiments where everything that is not, we cannot map anywhere else, we put here. And then all the work that is not platform specific but use case specific, for example, specific to machine learning on GPU use case like web application or service that is related to only that that use case but not to the platform itself, we put everything into the specific group, including the API specification for calls which are specific for this use case and not general for the platform. And this way we sort of we separate generic calls to the platform, which is basically have to accept only generic calls for computing, and the specific calls that need to provide information, that pertaining just to a call, just to a use case. So here is the repository for the API specification only for the machine learning use case, which is, and now we know, since we know who is doing what and who is the milestone owner, so this person will be responsible for basically that specification. Now, what else do we have? So these are what is the difference between platform APIs and service APIs. Now, the best case to look at how that sort of we imagine how this will work is to look at the machine learning on GPU use case and the sequence diagram. So we have a sequence diagram in the in this wiki. Now, so if you see, there are blocks, and these blocks, they are related to APIs. since we will be using a bunch of different APIs in the same use case, because every single use case will be using different components of the platform, and therefore it will be using these components will have different APIs defined. So for this particular use case, we have, so the first block is user request machine learning work, which is defined what kind of machine learning work and what kind of information user has to give is defined by the service API. So in the repository that I showed. Now, find suitable compute resource on NuNet when all this information is already working. I mean, we have all this information. We'll have to provide this information to NuNet platform in order to find suitable machine. And that is device management API. We have to define those calls that are needed for that by device management API. Then when we will know what kind of device will be able to run all this workflow, we have to calculate the price and the terms and time and price and all other, let's say, terms of the computation, which will be defined in compute API. And then when this is defined and the price is agreed between user and the provider of computing, we'll have to log the NPX tokens as needed for that computed work and to put that into the smart contract so that, and to sign them from all the parties. And that is tokenomics API. Then after this is done, the actual machine learning service will be deployed and will be executed on the compute provider machine, which is device management API. Because this is already generic, something that is going on in the NuNet platform, and NuNet platform will not know by itself whether it's machine learning or any other computing work is running. Therefore, it's device management API. Then result verification, I didn't write this, but this is compute API, because you will need to make sure that the result that is returned is what was being asked. And the seventh one is that, again, we switch to the tokenomics API, where if everything is okay with the result, the funds which were locked in step 4 should be released to all the constituents on the workflow, which means compute providers and maybe algorithm providers and maybe data providers in the future. And that works via tokenomics API. Therefore, we need to have the efficient workflow in order for us to define what kind of calls between the components we need between each component and within each API, and to make sure that we communicate within the team properly to implement those calls within these different APIs. And to, of course, update the API specification so that everybody then can access them and to see what is the latest specification and to develop on top of that. So, right. Now, this is something that I believe Ola will do much more, let's say, in detail, but I will just present how do we map the Git flow of our development to the API publishing. So we have few stages. So let me, actually, I just didn't finish it. Let me finish the picture and I will show you. So develop merge request in 3, then staging 4, and then 5. So basically, we have this kind of branching structure on our Git flow, where we have feature branch, develop branch, staging branch, and the main branch. Now, for now, we basically have only this one, but we also already sort of the whole structure of how we work. So the first one, a developer opens a feature branch from the develop and develops whatever specification that is needed, builds unique, and then when he or she pushes to the feature branch from the local, then the CI/CD pipeline builds unique API specification pages and provides a link to developer to check whether this API is what is considered, what is needed. Then it develops. Then we have merge request from the feature branch to the develop branch, which builds unique pages and makes it available for merge request reviewers to check the specification before merging. When we merge, free is when we merge actually to the develop branch, then we build public pages with a permalink, and that is available publicly both to the developers and to the community of developers and integrators, meaning that we can develop all the other features based on this API into the develop branch. When we decide to release number 4, then we kind of merge, well, basically we create a staging branch from the develop to staging. Then we build all these APIs here on the permalink for staging. We will be working, again, testing all the APIs, because this will be part of the testing. API testing will be part of the CI/CD pipeline. We'll be testing everything. And then when everything is tested, we will merge staging branch to the main branch. And then at this point, we will release those APIs as public APIs. And here, somewhere here, we will have to have versioning of APIs, which is something that we haven't yet solved, but it is coming as we need. So API development will go through those 5 stages, as explained now. And I think that's what I wanted to say. Very fast and efficient. Hopefully that was more or less clear.
Yes, it was clear. Thank you, Kabi.
Thanks.
Ola?
Yes.
Now, Ola will show how things are being doing in the pipeline, basically related to the last slide that Kabi showed.
Yes, indeed. Let's have a look. So these are the 3 repositories under the Open API group. So we have the tokenomics, device management, API spec, and telemetry. Out of all 3, tokenomics uses the async API. Device management uses both Swagger and async API, and telemetry uses async API. The general goal of the CI/CD pipeline has been outlined by Kabir. So let's have a look at how it works. There was a part of it that under Kabir's slides, there was a part of it that I don't think I patched properly, but the general idea is there. So first of all, let's look at the tokenomics API spec. This one is async API. So the only part there that was not fully complete was, I believe, that first one, because at the end of the day, I changed 1 or 2 things. So that is, it is only when the developer is developing on a feature branch, I didn't create that pipeline, because at one point I assumed that it's a local test, but that should be fixed. Sorry about that. It was working before, but I changed 1 or 2 things due to some complexity. But otherwise, how it works right now is that when you make a merge request from feature to develop, it creates an environment, a GitLab environment, that is a unique URL that you get that runs right here. So as you can see, the rules are, when you make a merge request, the pipeline runs, but when you are pushing to main or develop, there's no pipeline. And obviously, since the main branch and develop are both protected branches, you really cannot make a push directly there. So when a merge request event is done, we should have an environment whereby you actually get your published API. So generally, this is simple async API HTML generation. And this works for merge request to develop or to main. So now for the permalinks themselves, that is where these pages come in. So the pipeline runs when there is main, and when we are making a push. This push does not it's not like our this push is not like the general git push, but rather is a push that gets done after you make a merge. That is generally what a merge does, is that it takes the changes from here, puts it together, and makes a push all together. So the result of that combination is where this goes on. So, and generally it's the same script, and at the end of the day you get a result. So let's take a look at it together. So say I am a developer and I wish to make a change, and I want to add a new API to the tokenomics API spec. All right, so obviously I check out from develop, and I check out say for add new API. Cool. So we have our API, and I wish to add a new say I wish to change something. I'm not too familiar with async API, so I will just make very minimal changes. So let's say beta 1, and I change the version to 2.4.1. Then I'm good to go.
Ola, I think this async API is async API version, not the API version.
Oh,
yeah.
Okay. So I make a change right here. So the part where I seem to have drifted off from my original assignment was whereby when I make a push to my feature branch, I should get an environment. But it's only a minor modification here that I'll be making today. But let's move on. So I git add and do the usual push. Oh, sorry. Then I push. Now I should now normally with the proper review, I should get a pipeline starting to run, but it didn't run. But now if I want to, now after finishing making all my changes, I will obviously make a merge request. So I'll make a merge request from my feature branch up till develop. Oh no, I'm not closing for, sorry. So obviously I change branches. All right, so yes. So now once I know I'm not closing for again, what? Assign to me delete source branch roughly. Then I should get a merge request with a unique URL. So while the pipeline is running, at the end of the day, I should get, me as the developer, I should get a live version of this my change from the merge request. So right under the merge request, it will tell you where it's deploying to. It uses a GitLab environment whereby GitLab provides you their own environment to deploy stuff, or you can also do it on premise. So this takes generally about 2 minutes before we get things done. Okay, so generally that's we should get the unique URL here. So oh wow, that was done quickly. So once I refresh my merge request, I should find where it is deployed to. So all I do is I click my view app, and here we go. As the developer, I will find my latest changes, and whoever is reviewing this merge request, as it has not been merged, can actually go and see how it looks and make whatever modifications right here. Now, say everything is all fine and good, everybody is happy. Is it okay if I merge? I hope I'm not gonna.
Well, we'll have to take it back probably, send by another mesh, so that the develop stays what it is. But yeah, I think we can show it.
Okay. So now everybody is good to go. They're happy with the way everything looks. So the reviewer merges. Now a pipeline will start running. That is, the pipeline from the merge should start running and give us a permalink. So now permalinks. As you can see, the difference between, as you can see right here, we have some kind of weird and unique URL that does not stay the same. It uses the pipeline, the job ID to generate the URL. That's not very sustainable. But so therefore, we chose that for specific branches, we are going to have permalinks using the branch name. And these branches are develop, review, or staging, and main. So I'm going to only show the result of develop so as to quickly take things quickly. So if I also make a merge request from develop to review, I will get a unique URL. And when I then merge it, the results to staging, I will get a permalink up to staging, and so on and so forth. Like Kabir mentioned, we are still working on versioning, as it is very, very important to be able to see revisions over time.
I think we can show the README file now, where you actually list all the permalinks.
Okay, so on the README file, we will find. Ooh, I thought I edited this. All right, it should be here. Develop. All right, so upcoming features and review are under environment. So okay, we've gone through that. You can see it from the merge request. So we have three main links. We have the develop, staging, and main. So if we have our pipeline working fine, I believe it works fine now. If I go and develop, here we go. It has been updated. So this is what the anytime, anywhere, if you have /develop, you are good. You're gonna have your.
So this, if we're just to add a little bit, so the alpha develop branch will hold all the kind of bleeding edge API specification which is published, and which will be working on our developed network and develop branches, which will be built from developed branches. And this will be permanent link. If you go to this link, you will always see the bleeding edge API specification. Yeah.
So when we are done, we make a merge to staging, and from staging to main. So finally, the only unique, and this goes without saying, it's the same working methodology for both tokenomics and telemetry. The only unique one is device management API spec. Why is it unique? Because it uses two versions of API generators, both Swagger and Async API. So the source for this Async API and both Swagger doesn't come from here, but rather comes from device management service. So what we did was that we're watching for primarily two files. We're watching for, okay, here we go. Yes. So primarily we are watching for two files. Okay, we're not really watching for them every time we do it. So we are gonna clone our API spec, right? Set up whatever Git config is necessary. Then after we've cloned it, we do a move of our current swagger.json, our latest swagger.json, and our latest API spec. We move it into the cloned branch. We moved it into the cloned folder. Sorry. Then afterwards, we check that there were changes. If there are changes, if there are new additions, we then make a push back to device management API spec. When the push is done, obviously there it will see that there's a new push. I need to run a pipeline again there. So when the push is done, keep bouncing to main. Yes. So when it sees that a push is done, it will immediately when it sees a push is done and it's done to main developer staging, it will start generating the link. So the permalink. So what we did for async API was generally straightforward. It's what we did for tokenomics and the others. But what we did for Swagger was that since we didn't have something that would generate Swagger like URL, all of them looked like clones. What we did was we cloned the Swagger UI, obviously, then made one or two changes here, and yeah, there we go. So at the end of the day, we should have our permalinks set as well. So if we go to our develop branch, we should have our device management API, and right here we should have our Swagger as seen below. So this also works using, this does not care about merge requests, but primarily pushes from device management service. So that's a general overview. I hope I didn't speak too fast.
No, it was perfect. Thank you, Ola.
Okay. So, Ula, you've done?
Yes, I believe so.
So
Okay.
now I think it's good for us to decide whether we go to time management or whether we have discussion if anybody wants to sort of clarify anything from what Ola was.
Is there any questions before we close up this topic? If you guys want to discuss.
I have one question. So, Kabir, my question is for Kabir. Kabir, is it okay if I leave the feature branch the way it is, whereby it doesn't generate a unique URL, or I go back to the original plan?
Why doesn't it generate now? Basically, I think, yeah. Basically, it should generate for the developer. Yeah.
Okay.
I think we don't generate it because developer can be doing
it locally, since it's
yes, and doing many pushes. Every time he did a push, the structure will run again.
Okay, right. We can basically do that, but then we have to explain and all this stuff, because this was, I was thinking of another flow when I was explaining, but yeah, if you decide that this is better, I'm not sure whether developers will know. Well, probably they will know if they will develop APIs that this is how to build them and how to look at the results. Okay, then let's generate it only on the merge request.
I will update the README for them to see how to generate it locally.
All right.
Okay.
I have a question.
Sure, Santi.
So the async API of DMS is showing, I think, tokenomics API. Is it just for testing or?
Yes, correct. Janina asked me to update that both General and Kabri has went through. Remove that. It could be confusing. Yes, you're right.
So this is just because we haven't yet defined the sync API for this, and therefore we used I used like from tokenomics API just a template in order for the CI/CD pipelines to work. So we will delete everything and leave some kind of mock call just for the file to be there. So
yeah, got it.
Okay. Any other questions, Ula?
Kabir, I was thinking, could I show a small demo of the HiOS system just right now?
So we have 15 minutes, so probably we will. But yeah, fine. I think maybe we go with these songs. Look, what do you think? And we keep the time management for next time. Which
I was thinking the same thing. Yes, yes.
All right. So Avi, please go on.
Yeah.
Yeah. Okay.
Go ahead, Avi, please.
Yeah. So can you see my screen?
Yes.
Yeah. So this is actually the main interface of HiOS. And these are my GPUs that I've been using for my research purpose and funding as well since my PhD. And here what I wanted to discuss was this particular thing called flight sheets. So this is the flight sheet that I've configured as a template so that I was thinking for our use case. So in the minor issue, so here I have specified this URL, which is which all of you are acquainted with, and for password, I was thinking if we could have a mechanism to use ACL tokens, and in minor we could use this particular NuNet name in the minor section. And for template, we could use the worker name. A worker name like it would be the name of the onboarding machine, the host name of the onboarding machine. And in install URL, we could specify the DMS package that Santosh is developing. And in user config, we could provide commands such as watch the nomad status. So when the miner would be running, so this thing would show up on the console. So we could let me show you the editing thing. So what I've done here is first I've created a custom wallet, and there after that I've that wallet address could be an ETH token, ETH NTX wallet address, and then we could have the this is a test, and this will be like a hash that we have for NTX wallet addresses. And this particular thing is the pool would be like, in place of the pool, we could use the nunet.io with the 4646 port in this particular thing. And here is the main thing where we can configure our onboarding. So set up miner config. Yeah. So this is the thing which we can repurpose for our ML use case. So this is generally used for mining, but for our NuNet use case, the NTX for it would, we could say that we can mine NTX using this format. So here we could this is generally used for downloading miner packages manually, like those miner packages that we cannot download from that is not in here by default. So those packages are some miner packages would be not be available in HiveOS. So people could specify those miner packages in this particular URL. So what I was thinking was we could use a similar approach for our DMS also. And here we could have the pass the ACL token here. Somehow we could have a mechanism to pass it as an authentication mechanism. And then we could perhaps then run this flight sheet, and we could say that we are mining NTX. And on the what is happening on the other end is that the machine learning is users are running their ML jobs. So that's what I wanted to discuss. And one more thing is here we can also tune. There's one overclocking feature also. So these are basically the miners. Overclocking feature, yeah. So here the main thing is we can have a lot of options to fine tune our GPUs. Like we can set a power limit in here, and that would be that would be very good for managing the GPUs efficiently. So there will be a lot of GPUs on the network. So we could have the onboarders could set a power limit here, and it would we could have a proper way of managing things in here. Yeah. So, and this is the fan percentage, and this is one interesting thing. If you set this as 0, what would happen is this is set to auto fan. So when suppose the miner, suppose an ML user sends an ML job request, and once the job is received, when the job would be running, it would automatically, the fan speed would automatically change depending upon the what to say, the intensity of the job that is running. So this is a very useful thing in here, so that we can make use of. We could always set this to 0 for onboarders, so the GPUs would be managed very efficiently. Yeah, so that's all from my end. Thanks.
Thank you, Avi. I have a question about is it a proprietary framework?
This is based on Ubuntu. HiVoice is based on Ubuntu Linux.
Okay, but I'm asking about price. It's
that is free,
proprietary,
free of cost.
Yeah, well, it's open source. I think this is
HiVoice.
HiVoice itself.
I don't think it is, but it is they have one. I can show you the HiVoice website here.
So I would like to kind of position all this discussion where it stands in our development pipeline.
Yeah.
And where it stands is that Avi filed basically not exactly a feature request, but how do we call it? Development proposal, whether we can use HiveOS and how we can use it for managing GPU clusters. So in terms of our development, I mean, there are few things which is related to that. For example, we do not mine NTX, and we do not plan mine NTX because there are certain things that we have committed during the token launch. We have stable supply. Now, therefore, we may, I mean, I believe that we may find certain things that we may or may not, I mean, try to see what we can build and how we can sort of integrate HiveOS. So, but basically what we're discussing a proposal, and this proposal is something that we will do when we will sort of do the second part of the way I'm imagining, when we will do the second part of the machine learning on GPU, which means we will build not only machine learning workflows using not only single GPUs, but we will build GPU clusters within NuNet. And then it may be very interesting to see how this is done and to see whether we can integrate. So this is a proposal for that part. Yeah, I'm just kind of positioning this into the development flow. Yeah.
Thanks, Kabir. Thanks.
Okay. Well, I think we can wrap up for the technical discussion today. If there's any more questions, and then we can start our daily report.
Well, I thought we still have 7 minutes, right?
Yeah.
So what about if anybody has questions regarding time management, a little bit more specific, so that we could possibly prepare for the next week?
Sure. Sure thing. Any questions, guys? Any thoughts?
For me, not really a question, but more, I actually look forward to hearing ideas on how to improve time management.
Well, the thing with time management is it's very personal. So what we can do, we can share all kind of tips and tricks that we use, but basically there is no like one fits all. And therefore it will be kind of a discussion rather than So I would like to invite to either, let's say we can write questions to the technical discussion beforehand, but basically it will need to be based on the feedback. What is the need? Because it's really a very personal thing. Something that works for me will not work for anybody else, and the other way around. It's like something that we will have like a bag of tricks which we can share between all of us, and then figure out what fits for everybody. Of course, there are certain general rules and there are certain sort of ways to collaborate. But yeah, this is a comment. Therefore, we'll have to have a lively discussion about that rather than some sort of presentations like this, like today. All right. So then, if there are no other comments regarding that, so let's move to the daily.
Okay.
Okay, right. Just let me share the screen.
I think we can stop recording, or are we recording daily?
Shall I stop recording?
I mean, we can record the daily, no problem.
Okay. Okay, right. Santosh, can we start with you?
Yeah.
Right, let's right.
So final part of this task is to send a message to a particular node. So today I the schema of DST was changed. So I told Barek to he will look into it. But I also tried sending a message by passing this as a test, and the message I sent to that node was also not working as verified by Podros. He told me he didn't see the message. The message should be seen. So there is a problem at that end as well.
So I've been looking into that, and I've just now managed to find a fix for that. So like a couple of before the technical discussion. So you can maybe now try it. So it's now working. You can receive the message.
Is it working, or will you be implementing?
Yeah, I've already tested it by running an adapter on my device, but maybe you can check it and let me know if there's any issue.
Cool, I'll let you know. Okay, thanks.
Okay, good. Right, thank you, Santosh, and of course, thank you for this for your help. Devendra, your mic is mute.
Hello.
Yes, hi.
Okay, so I'm trying to run the NuNet adapter. I ran into a couple of errors. I checked with Chidros. He helped me to overcome them, and I can see that it's running. And I'm just playing with him and try out to see what it's there and how it is working. And I'll keep further. I will keep more changes on that. And after that, once I have the full understanding about the NuNet adapter, I will try to build the task A, which is to create a route to accept to handle the request or to get the data from other peers.
Okay, all right. So I got that B, C, and D will be done by Monday, right? I got it correct?
Yeah, actually, I can only confirm like they are done once the task A is done. Like the flow will start from the task A, then it will go till the last one.
Okay.
So like it depends on the one as well. So like you can say it's kind of a component which is kind of done, but still it has to integrate and connect to each other.
Okay. Okay. All right. Twadros?
Okay. So with regards to this issue, we had a meeting with Umer earlier. So I've shared with him all the research that I've done and where I'm currently at. So he's looking into that, and I was also working on trying to fix the issue that Santosh mentioned. The message was not being received by the DHT populating script. So I've now managed to fix that.
Okay. Okay. Good. 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 All right. Avi, you here?
Yeah.
Hi.
Yeah. So I was working on the ML web app overview. So I've created an overview of the diagram. Yeah. If you could scroll down. Am I audible?
Yes, you are.
Yeah. If you could scroll down.
Okay.
Yeah.
Okay.
Yeah, so this is the ML on GPU web app overview that I just picturized and have drawn here. And Kabir was asking about the plus symbol here. So actually, it is when we click on that, we should be getting more text boxes, so the ML user can enter more dependencies and more package names, and so it would be sent to the Docker file for accordingly that we can discuss in the next stage. So I've commented in there also. If you could just scroll down a bit. Yeah, so here I have described it. Yeah.
So is okay. Okay. All right. Any questions, guys? Junaina, Kabir, Dagan?
No,
Nothing
Avi
for me.
Yes, please, Dagi.
No, I said I had nothing.
Okay.
Yes, Avi is almost finished this issue, and this will be used by Khaled in order to create the web app application. And we also need to add parameters from tokenomics part, but Safi needs to define it. I think this task will be on review on Monday.
Actually, I think once we have the in the prototype of the ML web app, perhaps we could share it on Twitter and other places where on the ML community, so that they would get interested on it. Yeah.
Okay.
Thanks.
Okay. Right. Thank you, Avi. Right, Ula?
Yes. So for my task today, I'll split them into two primary things, which is to review the image generation code. I've tested the description and everything works fine. So, and the code actually works fine, but there is one thing I need to fix, which is since we have multiple epics rather than one, so the 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 epic name or the milestone name. Sorry if I keep switching terms, but the milestone name, if I'm correct, is currently hard coded. So I need to make that dynamic, perhaps using an argument. So that's one thing I need to fix. But for B is I would say primarily done because I have I have a pipeline running locally that kind of pushes to the same repo without triggering a a pipeline loop. So it's only this A that remains, and it's a small task that, fingers crossed, I will work on it today before the end of today. If uh if I don't run out of time.
Okay, well, thank you.
Sorry, I was speaking on mute. Okay, right. Thank you, Ula. Omer?
Yes, so today I had a meeting with Tevotros regarding the issue he is facing on encryption of file system. So I took all the resources that he has used and what are the issues exactly he is facing. Also, I had a meeting with Ilya to configure his new computer. He has bought a new computer, so there was the device encryption and all the other things were to be set up on his computer. So I was working on him for that, and also I had a meeting with Santosh to understand how DMS works and what are its inflows and outflows regarding the NuNet. So and also I'm preparing a mobile checklist that Kevin asked. Kabir asked. So yeah, that's pretty much it that I did.
Okay, right. Any support needed from anyone, Omar?
Not right now.
Okay. Okay, right. Good, good. Khaled?
Yeah. Right. So I actually am not. I don't know if it's on the ticket or not, but I'm going with that React stuff. So I definitely need some time on it. But I'm making like good progress on it. I've advanced like almost 40% of it in the last couple of days. So I think I should be able to finish in 5 days, as I told Dagam and Janina.
Okay.
Right.
Okay.
I wonder, did you? I mean, how does it integrate to what Safi done? I missed. Does it integrates or which part, or is it related to just the part that Avi wireframe?
Actually, Khaled is not in that point. He is researching about reactive, and after that he will go into this issue and understand what really needs to be done.
Okay.
And until there, we will have time to have a Safi part of tokenomics. Avi is already done, and we will have Safi part so Khaled can understand better what needs to be built.
So we'll talk about how to integrate tokenomics with that app with Safi. Okay.
Yes.
Janina, I wanted to add one more thing regarding the mining operating systems.
Okay.
So the thing is, HiveOS is just one of them. So we have others also, like Simple Mining OS, and we have Miner Stat. So all of these operating systems have a similar kind of interface. So we could go for any of them. So that's why I wanted to add. And HiveOS also is also having a particular script that one can run on Ubuntu, and it would be transformed into HiveOS. So that's all I have right now for this. Yeah.
Okay. Thank you.
Right. Okay. Thank you guys for today's call. I think we passed time, but we're in good time. But we think we're done here today. Any questions before we close? Any thoughts?
No, I just want to thank Kabir and Ola for the presentation, and also Avi for sharing. Yes. Thank you, guys.
Thanks.
All right. Thank you guys. Have a lovely weekend ahead, and see you on Monday.
Yes, thanks a lot.
See you. Have a nice weekend.
Nice week. So have a good weekend. Bye.